Why are we writing? We didn't have to do number 7. What? I did the homework. I did the homework.
Oh yeah, no problem. Yeah, don't be disappointed when they walk off.
I can show you I did the homework, Mr. Bart.
Look. I told you I'm going to check the homework every day, but I don't need to check on the first day because who would be stupid enough to not do it? Who would be stupid enough to not do it when I said I'm going to check? Okay, here we go.
Homework check done?
Don't worry, I have my days. I've been teaching for 20-something years.
Oh no, this green. Wait, 27?
Why are there so many numbers on here? Can you show me up? Huh? 1C. Okay, wait. You gotta make sure we're on this camera. Yeah, right there. Limit x approaches infinity. Sine inverse. Yeah, a lot of these problems are from previous AP exams, you know, so make sure you can do it. Now, the sine inverse scares you. Okay, just do it without the sine inverse first. What's the limit of the thing in the parentheses? 1/2, right? The degree of the top and the bottom. I'm saying you look at the coefficients. This is 1/2. It goes to 1/2. So that means the thing is getting closer to sine inverse 1/2. Sine of what angle is 1/2? Pi over 6. G. Limit x approaches pi over 6. F of x minus f. Are we starting to memorize that cheat sheet?
Yes.
And f of x is equal to cotangent x. Now, as soon as you see this, what are you thinking? Hey, do some derivative. That's the definition of the derivative, right? Yeah. Remember, you got two definitions of the derivative. This is one of them. The derivative of what function? No, the one that's it's So what you need to do is you need to take the derivative of that function and then you need to compute it when x is pi over 6. So the derivative of cotangent x is? Negative cosecant x. And then you plug in pi over 6. That's the hard part. Yeah? Let's impress our guests. So negative cosecant pi over 6 squared. What is cosecant pi over 6? Louis! 2. Think you're good now? So the final answer is negative 4. So what was the problem with that? Okay, don't answer me. No, I'm serious. You guys gotta recognize definitions of derivatives. So that would be E, F, G. Are they up there? Number 3, f of x is equal to cosine 2x plus 2 sine x. For what values of x between 0 and 2 pi is f prime of x equal to 0? Okay, so first step, we need to compute the derivative. Suzaki.
It's negative sine 2x times 2 plus 2 cosine x.
Okay, and we want to know when is the derivative equal to 0. So we just need to solve this equation. Now on the AP exam, I'm telling you right now, you gotta know your double angle identities. They test you on that all the time. Just sine and cosine. I've never seen one where you have to know tangent 2x. But sine and cosine, double angle, you need to know. So right here, what am I going to do with the sine 2x? Okay. And then now, come on. We're talking to take it from here, right? So we got negative 4 sine x cosine x plus 2 cosine x equals 0. What can I factor out?
Negative 2 cosine x.
Yeah, but come on, the first term is negative.
Just like negative 2.
Negative 2 cosine x. Yeah, but you know by now I don't listen to you. So what's left? 2 sine x.
Minus 1.
Minus 1 equals 0. So equating each factor to 0, you get cosine x equals 0, and sine x equals 1/2. And are these numbers we're supposed to know? Yes, cosine of what angle is 0? Sine of what angle is a half?
5 or 6.
Well, I can read the answers on the bottom too.
It's not on the bottom.
It's not?
It's not on the bottom.
It's on another page. Congratulations.
Wait,
I searched for 'em.
Number 2.
Wait, I have to do my eats.
Okay, number 2. So this was your problem, Suzanne. E to the x minus 1 over e to the x plus 1. Compute f prime of natural log 3. That means you take the derivative and you plug in natural log 3. Okay, now I see a quotient. So how do I take the derivative? Should I make up my own rule or should I use the quotient rule?
Make up the quotient.
I thought it was the bottom derivative first, but then I came up with a negative number.
Low d high minus high d low all over denominator squared we go.
Oh, I was thinking u d.
Okay, Lau, apply the quotient rule, go.
D squared we go.
E to the x plus 1 times e to the x minus e to the x minus 1 times e to the x over e to the x plus 1 times squared.
Low d high minus high d low all over denominator squared we go. How can we forget that?
It wasn't on the cheat sheet.
Okay, if it's on the cheat sheet, you have to change classes right now. It's on the, not,
I didn't find it.
okay, look at the list of derivatives and integrals. Where is the list of derivatives and integrals?
It wasn't on the first.
Where is it? There it is. Oh, the derivative of u over v is, there's the quotient right there. Bye-bye.
It was on the first page of the cheat sheet.
Okay, now you have to plug in natural log 3. If I plug in natural log 3 for x, come on. What is e to the natural log 3? 3. This comes up all the time on the AP exam. E to the natural log banana is banana. So if I plug in natural log 3 here, I'll just do it here, 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 and there. That's just 3, right? So you got what? 3 plus 1. 3.
Times 3.
3 minus 1.
2.
3.
3.
3 plus 1. I think you guys can take it from there, right?
No.
I can't believe that problem was on the board.
Are you surprised?
Don't feel bad. Don't feel bad.
He does it. Wait, Ms. Mark, I thought you said only the first page of this was the cheat sheet. There's one sheet.
No, that's the Bible, but you also have got to know all your derivatives, integrals, and trig
I thought
identities.
it wasn't on the Bible.
Number 4. Oh, come on. What do you do when you see absolute value? You make a piecewise function, or you just ignore it, pretend it's not there. So piecewise function, okay, so you look at this. This is either equal to itself or the opposite of itself. That's how absolute value works. So x is greater than or equal to 0, x is less than 0. So when the inside is positive, you leave it alone. When the inside is negative, you negate it. There, you make a piecewise function. Now we can answer the question. Compute. What is the limit as x approaches infinity? Now, which piece do I look if x is approaching infinity? Yeah, because x is greater than 0. You look at this piece right here. So what's the limit as x approaches infinity?
2.
2. If the degree of the top and the bottom are the same, you just look at the leading coefficients, right? What's the limit as x approaches negative infinity? Then you look at this piece. The degree of the top and the bottom are the same. You look at the coefficients, -2. It is that simple, people, but you have to write the piecewise function. What is f prime of x equal to? Well, I see 2 quotients. You're going to have to use the quotient rule here and the quotient rule there. Do I really need to do it?
No,
Okay,
just
well,
look at the bottom.
low
Just look at the bottom.
d high minus, I'll just do this quickly, high d low, all over denominator squared we go. And then low d high minus high d low, all over denominator squared we go. And then I will leave the simplifying to you.
Or just the.
And then you need to compute f prime of 0. Now what? That means you have to plug in. Now what does f prime of 0 mean?
What's the slope?
What is the slope
It's 0.
when x is 0? So how do you do that? I got two pieces, Mr. Park. Which one do I look at?
Well, they gotta.
You gotta look at both, because in order for a function to be differentiable, what?
Gotta work it.
What does differentiable mean again?
Continuous.
Smooth and continuous. So that means when x is 0, in order to be differentiable, it's got to be smooth and continuous there. If it comes to a sharp point, then the derivative doesn't exist. So how do I tell if it's going to be smooth or not smooth? No.
You look at the derivative.
Yeah, you look at the slope. You look at the slope on the left and the slope on the right. If the slope on the left and the slope on the right are the same, like okay, let's make a hop. Let's say something like that. If the left-hand slope and the right-hand slope are the same, then it's going to be smooth, right? But if the left-hand slope and the right-hand slope are not the same, then it's not going to be differentiable. Okay, so what you need to do is after you simplify this, or I guess you don't have to simplify. If you plug in 0 here, that's going to be is that the right-hand slope or the left-hand slope?
Right hand.
Because it's greater than or equal to 0. This is going to give you the right-hand slope. If you plug in 0 here, that's going to give you the left-hand slope. If they come out to the same number, that means it's going to be smooth. So it's going to be differentiable. But if it comes out different, then sharp point, derivative does not exist. So what did it come out? Or do I have to actually?
They're not equal.
So what did the first one come out to?
1 over x. 1. 1.
1.
Yeah.
No, 1.
Okay, let me look at it.
Yeah, then just.
1.
Where's the answers?
It's 1.
Silence. It is 1, Suzaki.
Okay.
Wait.
Other one's 3.
And the other one's 3. So if the right-hand slope is 1, what does the slope of 1 look like? And the left-hand slope is 3, it looks like that. So it comes to a sharp point, so this does not exist.
Undefined.
Yes.
Oh.
Because remember the definition of absolute value? What's the definition of absolute value? It's equal to itself when x is greater than or equal to 0, and it's equal to the opposite of itself when x is less than 0. So whenever you make the piecewise function, it's always going to be this and this. It's always going to be that. Okay, how far did you guys get? Is number 5 on the board?
No, 6B.
They're leaving.
No, 5B.
They're leaving. No, I just want to make it.
Thank you very much.
Thank you. Bye.
Was that best behavior, Mr. Park?
That's a person, he's evaluating me, so if I get the okay, I get a $200,000 bonus. I believe there's like 5 people applying for Miss Yanashige's job. You know, what is her title right now?
Dean of students.
Oh, I thought she was special.
No,
Special office.
Assistant head of school.
Oh,
Nah.
it's not headmaster.
Anyway, they're applying for a job.
Because he doesn't want to be called headmaster.
Wait, what?
Wait, so she's not going to be here next year?
No, she's gonna be
Gonna go back to special.
So they changed the
Special programs?
next year
Wait,
already.
then what is
I thought she was gonna stay on 1 more year. And then she's gonna go. I don't even know. Why are you gonna ask me?
Wait,
Next! 5. We're just doing every single. How are?
I did the homework!
I need time to lecture on the thing that you're supposed to know for the next thing. We cannot be just doing every single problem.
I promise.
Cannot.
I did the homework, Mr. Park.
I heard something. Write the linearization. Okay, what does that mean, linearization?
Make a line.
A tangent, the equation of the tangent line. Now, what are the 2 things you need to write an equation of a line? Point and the slope. Okay, now, they gave you the x coordinate. How do you figure out the y coordinate? You plug it in. So plug into there, you get 9 to the 3/2 power. 9 to the 3/2 power, which is 27. Then you have to find the slope. Well, that comes from the derivative. Okay, who's taking the derivative of this? Love J.
3/2 times 4 plus 1 is
I said times star.
I didn't hear you.
I said it after the 3 house.
Okay, don't forget to multiply the derivative of boxes. That's a fatal error on the AP exam. I can tell you right now, almost every single problem, you're going to have to multiply by the derivative of box. Okay, do we even need to simplify? No. Let's just plug in 2 here. If I plug in 2 here, you get 9 to the half, which is 3 times 3 half times 4, but 2 goes into 4 2 times, so that comes out to 18. Oh, that's a steep slope, yeah? Anyway, once you got the point and the slope, just do point slope form. Y minus 27 equals 18 times x minus 2. But when we do linearization, what do we do? You guys remember? Solve for y. So do not distribute this 18. I'll just leave it like this. Now, if you look in your notes, there's a formula for linearization, yeah? I would suggest don't memorize that formula. Just write the equation of the tangent line like I taught you, just like this. That formula, just the formula that's in the book, which is the same as that, but why memorize another thing, right? Just write the equation of the tangent line. And then it says, use your result to estimate f of 2.1. Okay, now do you guys understand what's going on here? You have a graph. Okay, here's a function here. Okay. What we did is when x is 2, right there, when x is 2, we wrote the equation of the tangent line. Okay? Now what we want to do is we want to estimate f of 2.1. So on the actual curve, 2.1 would be about there. F of 2.1 is the y coordinate of that point there. But who wants to plug in 2.1 into this? It's very difficult. So we can get a good estimate by plugging 2.1 into the line equation. Because can you see that the y coordinate of the line is very close to the y coordinate of the curve? As long as you're close to this point, and this is the concept of linearization. When you are close to this point, the y coordinate of the line is almost the same as the y coordinate of the curve. Of course, if you go further away, then there's more error, right? So as long as you're close, you're going to get a good estimate. Okay, so all you have to do is take 2.1 and plug it into your line equation. And that's why you leave it in this form, because look, what's 2.1 minus 2? Oh gosh. 0.1 times 18, 1.8 plus 27, 28.8. That's why you leave it in point slope form, because it's easier to plug in the number. So this is a good estimate of what the actual value of taking 2.1 and plugging it into that. It's going to be very close. Now, the question is this an under or an overestimate? You remember that? How do you tell if this is an under or overestimate? It depends on the concavity of the graph. If the graph is concave down, then the point on the line is above the actual point. Yeah, so that would be an overestimate. However, if the graph was concave up, then the point on the line is going to be below the point on the curve. And then you have an underestimate. So how do you determine the concavity of the graph when x is 2? You need what? The second derivative. Second derivative tells you concavity. So here's the first derivative. Let's simplify it. First derivative is equal to, what is 6 times 4x plus 1 to the half. So we need the second derivative. Throw the 6 on the side like an unwanted pet. Take it from there. Hurry. Okay. So let's simplify it. Isn't that just 12 times 4x plus 1 to the negative half? Okay, so when x is 2, you plug in 2 here. What happens when you plug in 2? 9 to the negative half. 9 to the negative half. 1/3 times 12 is 4. So if the second derivative is positive, what does that mean? The graph is concave up. So that means the graph is concave up like this, which means that the point on the line is below the actual point, so that's why this is an underestimate. Now on the AP exam, when they ask you why, you have to explain in words. So you gotta say, this is an underestimate because f double prime of 2, what number did we plug in? 2, is equal to 4, which is positive, which implies f is concave up. But of course you can't write CCU because you need a legend otherwise.
That would be J.
Do you guys remember doing that in the first quarter?
No.
Yeah, I didn't think so. Okay, what time is it? We're in trouble. We are in trouble. We're in big trouble. So you know what? You know what I think is gonna happen? End up happening? You're gonna take it home and then you're gonna be on your own and you can't do anything, so you're just gonna write all the problems. So what's gonna happen is I'm just doing everything on the board.
Okay.
No. Yeah, that's what's gonna end up happening because I'm a pushover. But that's not what's supposed to happen. You guys we learned it. Come on, it's like a stab in the back.
The black man and the black girl with the black cat's not even there.
Okay, is this function continuous at x equal 4? How can you tell just by
Just plug it in.
yeah, if you plug in 4 here and you plug in 4 there, do you get the same number?
Yes.
Yes. You plug in 4 there, you get 2. You plug in 4 here, you get 2. That means the two functions, this is a piecewise function. That means that 4, here, let me just draw you a graph, even though you don't really need the graph. So you got a square root function, it's like this, and 8 over x, what does 8 over x look like? 1 over x, except, so it's coming down like this, then yeah? Something like that. So yes, it's continuous because look, you can draw it without taking your pencil off the paper. Okay, but what if they ask you on the AP exam, and they will? Why? Is this function continuous at x equals 4? Yes, okay, you get 1 point. You want the other point? Why? Explain why it's continuous. I told you yesterday. The limit, you have to write this on your paper. The limit of the function as x approaches 4 equals, what's the, it's on the cheat sheet. F of 4, thank you. You just write that on your paper, you get full credit. You need to, so you gotta know all these definitions. Now the second question, is it differentiable? Now the way it looks now, okay, let's say you didn't even know what this graph looked like. Let's pretend it looks like that. How can I tell if this, now it's obviously continuous, but how do I know it's smooth there? We just talked about it. The left-hand slope gotta equal to the right-hand slope. So how do I figure out slopes? Derivative. So if your function is in pieces, your derivative is going to be in pieces. What's the derivative of that? You're supposed to memorize this one. 1 over 2 root x. Make sure you memorize it correctly. Some people still putting negative in front of it. What's the derivative of that? That's like 1 over x. That's like x to the negative 1. Negative 8 x to the negative 2, so x squared. That's the derivative. Okay, so if I plug in 4 here, that's going to give me the left-hand slope. So plug in 4. 1/4. So the left-hand slope is 1/4. If I plug in 4 here, you're going to get the right-hand slope. Negative half. Is that the same slope? No, so that's why it's not. It's continuous, but it's not differentiable. Those are 2 words you gotta know what to
Do you
mean.
have to explain for that one?
Well, if it says explain, but okay, I'm just doing them all already. Do I have to do number 7? Yeah. Okay, this is the derivative already. This is the derivative. And it's all factored. Where do you have a relative maximum or a relative minimum? How do you tell? How do you tell when a function has a max or a min? What do you do? What's the procedure? You take the derivative and you factor it, which it already is, and then you make a number line. Okay, now let's review what's needed on the number line. You guys were good before. I don't know if you guys remember what you did. Number lines have to be labeled. If you have a number line that's not labeled, they don't even look at it. We don't look at it. That's the first thing they tell us. That means you're going to have to write a paragraph. And I don't think you want to do that. So just make sure you have it. What numbers go on this number line?
Negative 1.5.
Negative half and 2. And then you test. Think of a number bigger than 2. 3. Plug it in. Positive, positive. Without even plugging anything in.
0.
Why is it positive? Because 2 came from here, even power. That means the graph is going to bounce off. It's going to be the same sign. Even power stays the same. Odd power switches. Or if you don't know anything, just plug in 0. Positive times positive is positive. See? Plug in a number smaller than negative half. Negative 1. Negative times positive is negative. Anyway, negative half came from here. Odd power is going to switch. Okay, now what do you need to write underneath this if you want to get credit? If the derivative is negative, that means the function is decreasing. So do I need to write f decreasing? What if I write y is decreasing?
That's wrong.
That's wrong, because y is not even defined in this problem. F is increasing. F is increasing.
On the test, can you just write one legend and use that for every single problem?
You're only going to do it on one. Because you only have 6 free response questions. They're not going to ask you the same thing on. It's going to be 6 different things. So you don't have to worry about that. Can I just write one f increasing all the way across?
No.
No, because at 2 it is not increasing because the derivative is 0 there. 0 means it's neither increasing nor decreasing. So you have to write it twice. Okay, so let's answer the question. Where do you have a relative min? So you would say relative minimum at x equal negative half. Just look at your number line. The graph is going downhill and then it starts going uphill. Isn't that the lowest point on the graph? Yeah, so there's a relative min at x equal negative half. Now I didn't tell you guys this before, because I'm just saving it for now. Before, this was good enough, but now, 3 years ago, they sent all the teachers emails and they said, this is no longer going to be good enough on the AP exam. You have to add another phrase. So you have to say, because f prime changes from negative to positive. So if you want full credit, you have to include this additional phrase because they want you to make the connection between the derivative and maxes and mins and how to find maxes and mins. You guys got it? So anytime you have a max min or point of inflection, you have to have the number line plus the sentence. Otherwise, you got to write a paragraph. Okay, C. Where are we going? Relative. Oh, darn it, that was B. We didn't do A. Where is there a relative maximum? Look at your number line.
None.
No, there's none. Right? Because if the graph goes down and up, where's the highest point? No more, yeah? And then C. Where is there a point of inflection? How do you find points of inflection? Second derivative. So what you got to do is you got to take the derivative of this. Now what do you want to do? Multiply it out or use the product rule?
Multiply it out.
No, are you crazy?
It's not that bad.
Okay, what if that was a 7th power there?
No, I'm dead.
Please, just use the product rule. Let us practice the product rule. Okay, whose turn is it?
Really easy.
Wayne,
See,
product rule.
you're in the same boat as me.
2 represents x minus 2 squared plus 2x plus 1 times 2x minus 4.
What?
Sorry, 2 times x minus 2.
Okay, there. And then you need to factor that. So, what can be factored out? A 2 and an x minus 2, right? What's going to be left if you take out a 2 and an x minus 2? X minus 2 plus, if you take out the 2 and the x minus 2, you just get that 2x plus 1. And that, see, this is the hardest part of the problem, is doing the algebra. So 3x minus 1, did I do that correctly?
Yeah.
Okay, so you make your number line, see how automatically label it? And I'm just going to do this quickly. 1/3, 2, plus minus plus, f is concave up, f is concave down, f is concave up, and I have my legend, so I can do that. So let's answer the question. Where do you have points of inflection? Now what is a point of inflection again? When the graph changes concavity. So look at this. Where does it change concavity? So you would say there's points of inflection at x equal 1/3 and 2 because, okay, why? Why is there a point of inflection at x equal 1/3 and 2? Very good. F double prime changes sign. Right? Because we're looking for a change in concavity, so we need a change in sign. It changes from plus to minus there and minus to plus. Now, if you want to make a separate thing and say, because at x equal 1/3, f prime changes from plus to minus, and then when x is 2, it changes from minus to plus, you can do that, but that'll take care of it all right there. Oh my gosh, we're in a heap of trouble. How much time do we have? Like 11 minutes? Oh gosh. Okay, today we have to cover implicit differentiation. Okay, you guys remember position? Oh gosh, I don't know. Oh man, we're in trouble. Okay, implicit differentiation. Okay, I'll do a problem very similar to this. 2x squared plus 3xy plus y cubed is equal to 7. Just make up something. Now, normally when we take derivatives, normally you have like y equal or f of x equal. Now, what happens if it's difficult or impossible to solve for y, like in this problem? Yeah, we do implicit differentiation. So you do implicit differentiation when it's difficult or impossible to solve for y. Okay, so watch. It's just a technique. It's very easy to do. Now you got to remember you're taking the derivative with respect to x. So that means when you take the derivative of x, you're going to get 1. When you take the derivative of y, you get like y prime or dy dx. Okay, so throw the 2 on the side. What's the derivative of x squared? 2x times the derivative of x, which is 1. 3 is a constant. Throw it on the side like an unwanted pet, and then you have a product. You got to use the product rule. Derivative of the first, leave the second one alone. First one alone, derivative of the second. And you can write either y prime or dy dx. It doesn't matter. Okay, I see box cubed here. 3 box squared times the derivative of box. And of course, the derivative of 7 is 0. So when you do implicit differentiation, you simply take the derivative term by term of both sides of the equation. And then now you have to solve for dy dx. So simplify, distribute the 3. Okay, how would you solve for dy dx? Put all the dy dx's on one side, put everything else on the other. So, oh gosh, I'm going to do this step by step. Huh? Equal negative 4x. Hopefully after a while you can skip a step. Factor out the dy dx. 3x plus 3y squared. And divide.
This is out of
Negative 4. How come I'm doing all the work? There. That's dy dx. That's your derivative. This will tell you the slope of the tangent line. And then you're going to have to answer some questions. I'll just see if you can answer the questions. And if you cannot, then I'll do it tomorrow. Okay, number 9. Okay, particle moving on the number line. Let's review everything. If you are given position, how do you figure out velocity? Yeah, you just simply take the derivative. The derivative of position is velocity. How do you find acceleration? It's the derivative of velocity, or the second derivative of position, right? Okay, this is like a fundamental thing you gotta know. Now, how do you tell if the particle is moving to the right or to the left? What tells you if the particle is moving right or left? Or if it's on the y-axis, up or down? Sometimes they throw in that wrench there. Instead of the particle moving on the x-axis, they make it move on the y-axis. How do you tell if a particle is moving up or down or left or right? What? You look at the velocity. The velocity. So you make a number line. So what you do basically, you make a number line for the velocity. I'm just making up something. So let's say your velocity number line looks like this. What is the particle moving to the right? Yeah, when the velocity is positive, it's moving to the right. When the velocity is negative, it's moving to the left. So from 0 to 1, it's moving to the right, and then from 3 to infinity, it's moving to the right. When is the particle moving to the left? When the velocity is negative, so between 1 and 3 seconds. How do you tell if the particle is speeding up or slowing down? You have to look at what? Velocity and acceleration. So what you got to do is you have to make a number line for both the velocity and the acceleration. Like, so let's just say it came out to this. Let's say, so you have to make these number lines. Okay, it might take a while to do that. When is the particle speeding up? When the velocity and acceleration have the same sign. So from 0 to 1, where else do they have the same sign?
2 to 3.
And then from 2 to 3. When is the particle slowing down?
From 1 to 2.
When the velocity and acceleration have opposite signs. So that would be between 1 and 2, and then from 3 to infinity. Is that coming back? That's all in the notes anyway. Okay, hopefully you can answer those questions. And oh my gosh! And then we were supposed to do up to number 12, 11. Okay, so tonight's homework, you gotta get at least up to number 11. Okay, number 10 is optimization. You guys remember how to do optimization? Like, what is the maximum volume of the box? What is the minimum volume of this sphere or whatever? Yes, the whole free response is nothing but word problems. Even the multiple choice, they're all word problems. What about related rates? You guys remember how to do related rates? Oh gosh. Okay, the bell's gonna ring, so okay, oh gosh. No, we're not doing plan B. Who said that?
We're in plan C already.
Yeah, so yeah, this is usually the problem. Remember, there's two branches of calculus, right? You get differential calculus, the study of derivatives, and then integral calculus, the study of integrals. Students have problems with differential calculus because it was so long ago. Integral calculus, you guys remember, right, how to find areas? Like revolve it about the x-axis. Okay, what about length of curve? Do you have to know length of curve on the AP?
No.
No, no need. And like I told you, you don't need to know shells either. However, if you know shells, it might help make some other problems easier. But on the AP exam, only discs and washers, that's it. And the only kinds of integrals you're going to get are either it's on the list or U substitution. There's no integration by parts. I don't want to see, if anybody does tabular, expect to be choked.
Wait, tabular, not
There is no tabular on the AP exam. There is none.
Wait, you're recording this.
Yeah, I don't care.
You just said-
I'm going to choke you. Okay, no tabular. Okay, we got 3 minutes left. I think we should do drills. Anytime there's free time in class, we do drills because you gotta know that cheat sheet right there. Okay, we're gonna start with Wang. We're just gonna go around the room. No paper. Wang. What is the derivative of 3 to the tan x?
3 tan x ln 3 times negative
Secant squared. The derivative of tangent is secant squared. How come we don't know derivatives? How can we not know derivatives and integrals?
Yeah. That's how
Tom, limit.
Then you'd say
H approaches 0.
the inverse of the inverse of the Sine x over x.
Silence. Sine. No.
This is going to be
Cosecant x plus h minus cosecant x all over h. What is this equal to? Hey, this was last night's homework. What are you thinking when you see limit h approaches 0?
That is the derivative of cos.
Okay, that's it. This is the derivative of cosecant x. That's the hard part. Maybe we need a speed quiz on Thursday.
No.
Yes, I think we do.
Oh, if it looks
How
like
can
that.
we not know the derivative of cosecant x?
Negative cosecant.
Yeah.
Negative cosecant x cotangent x. See, so the problem is we don't know our derivatives and integrals. That's the problem. I think you guys are good with the concepts, but you don't know the